Okay, number 13. Let's solve and graph on a number line. We need to get our variable by itself. So the first thing I'm going to do is subtract the 9. So I get negative 16. Subtraction does not affect the inequality, so we're going to leave it just like that. And then I need to divide by negative 4. Now, dividing by negative will reverse this inequality. Now, everything's going to stay where it is. That's going to be a positive 4. That's going to reverse. I normally do it underneath. I just don't have room. And then I have my n here. Now, you can graph it from that, but it gets a little confusing. If 4 is greater than n, then if you read it from the n is less than 4. It's just easier to graph that way. When your variable is in front of your inequality sign, and I need 4, so I'm going to do like 2, 3, 4, 5, 6. I got some extra ones there. Okay, all the numbers that are smaller than 4. Well, let's start at 4. Well, 4 is not smaller than 4, and we only shade the true, so we've got to make that an unshaded point, and that's the only way we can do that. And then all of these are smaller, so we're going to shade this way, and I'm going to shade all the way, including that arrow, infinitely to the left, right up to that dot. Okay, let's do the same thing with this one. Let's get rid of the 8. And I get 9p is less than, adding and subtracting does not affect the inequality, negative 171. Divide by positive 9. What you divide by, not what you divide into. If that's positive, it's not going to affect the inequality, so it's going to stay p, and I'll just have to scoot over. It's going to stay less than. Now let's go over and divide. It is going to be negative. And let's divide 9 into 171. Goes one time. Get 8 left over, and it goes 9 times. So we got negative 19. Now, number line was, I always count my negatives, because remember, zero's over here, positive to its right, negatives to its left. So I'm going to put me some points, and I'm going to start with like negative 17, and then negative 18, because as the numbers get smaller, they look like they're getting bigger. Okay, I've got p is less than negative 19. So negative 19 is not true. So we make it not shaded. And all the true ones are again to the left of that dot. Okay, number 15. Find the equation in slope-intercept form of a line that passes through negative 2, 5 and has a slope of negative 3. It's called the point-slope formula. And there's your key words, point and slope, point, slope. Okay, it says y minus y sub 1 equals m times x minus x sub 1. Now let's find what we need to fill in. Your x sub 1, y sub 1 are these numbers. So here's x sub 1 and y sub 1, alphabetical order. And then your slope is your m. So m is negative 3. So we've got, and I'm going to scoot over here I'm going to have to do this one. So let's do it to the side. I've got y minus 5. So I've got y minus 5 equals my m, which is negative 3, times x. Now you have to be careful on this one. It's minus your x sub 1. Well, my x sub 1 is negative, so it's going to be x minus negative 1, which is x plus 2, excuse me. X minus negative 2, so that would be x plus 2. Now, all we got to do is distribute negative 3x and negative 6. And then to get that in that form, all we got to do is get y by itself. And we have y equals negative 3x minus negative 6 plus 1 is negative 1. And there's my answer. Okay, number 16. Write the line in slope-y-intercept form. That means I've got to make it look like y equals mx plus b, which is what we just did here. So we've got 8x minus 3y equals negative 6. Let's get rid of the 8x. But because I need the x in front of the y-intercept, I'm going to write it negative 8x minus 6. I'm going to actually I'm going to commute that and move it around. Now we need to get rid of the negative 3. So we're going to divide through, all the way through with the negative 3. And we get y equals, now let's clean that up, because that's going to be negative over negative, which is positive. and negative over negative, which again is positive, and that's 2. And there's our equation for number 17. Okay, now we talked about standard form earlier, so it just says put this in standard form. So that would be, actually it's just in reverse, the x squared, the x, and then the no x's. So I'm going to write 5x squared minus 12x plus 6. What is the degree of the polynomial? Well, the degree of each term is the exponent. So in this case, that's degree 2, that's degree 1, and there's no variables in this one, degree 0. And the degree of the polynomial is the biggest one you see. So the degree of the polynomial is the 2. Name the polynomial by the number of terms. Well, if you have one term, it's called a monomial. 2 terms, like a bicycle, binomial. Oop, got my paper turned crooked there. So this is 3 terms. It's called a trinomial. Okay, percent change from 20 to 27. Well, it's a percent increase because I'm going up. And it's the change where you subtract them. And then it's the original one, which is your first number. So when I subtract those, I get 7, and the original one is 20. Well, if I'm going to write 7/20 as a percent, to me the easiest is just to multiply by 5 over 5. You can divide, make it a decimal. I'm really just trying to get the relationship out of 100. So to me it's easier just to multiply by 5 over 5 and write it as 35%. Okay, we're multiplying monomials. This is a term and this is a term. And numbers, we know how to multiply. Positive 5 times negative 3 is just negative 15. And when you multiply variables, you just add their exponents. You're multiplying 3x's times 2x's, and you have 5x's. And 4y's and 3y's will give you 7y's, and 1z, and 1z will give you 2z's. Z squared. Almost run off there, but I think you can see it. Now, this is called power of powers, because you're raising everything in here to the third power. So 3 to the third power means 3 times 3 times 3, which is 27. And then a to the 4th to the 3 is a to the 4 times 3, which is a to the 12th. So it's a different type of problem in this. And I'll show you an example here in just a second. And then b to the 1 to the 3 is b to the 3. And then c to the 2 to the 3 is c to the 6. Because here's the deal. If you have, like, I'll use different letters. If you have m to the 3 times m to the 2, that's m to the 5th. You're multiplying 3 m's times 2 m's, and you have 5 m's. Now, if you have m to the 3 to the 2, as we talked about squaring something or raising the power, that means m to the 3rd times m to the 3rd. When you're squaring it, you need to multiply 2 together. Well, again, that's m to the 3 plus 3, which is 6. So, see, the shortcut on that one is to multiply them, and the shortcut on this one is to add them.